All right, so here we are with parallel circuits. We're going to look at how we calculate resistances and voltage drops and current in parallel circuits or components of circuits that are in parallel. Here we go. So parallel circuits offer the current more than one pathway to go through. The current comes out of this picture here is showing direction of charge movement, right? Current we count flowing the other direction. So the current comes out of the positive side of the battery and comes to a junction, at which point some of it splits, goes one direction through R1, other direction through R2, splits here at this point, at this junction. Some of that current goes through R3. All that current comes back together after junction 7 here and back to the battery. Now, because that current splits at each of these junctions, it should be clear that the amount of current that goes through each resistor is less than the total current that goes through the circuit. But if we were to add up all the current that goes through each resistor, it's going to equal the total amount of current through that whole circuit. So this will be our first rule of parallel circuits, that the current adds up through each circuit element to equal the total amount of current in that circuit.
Now let's think about voltage drops in a parallel circuit.
Imagine I've got like a 12-volt car battery, and I stick 2 vertical rods into the soft electrodes of that battery. So the potential difference across those electrodes is going to be 12 volts. If I then clip the leads of a light bulb onto those vertical rods, the voltage drop through that light bulb is 12 volts. Now, just like an ideal wire, we're going to say that this metal rod and the wire leads for the bulb have essentially no resistance. So there's no potential difference from one spot to the other in this short length of a conductor. Only the bulb has a potential difference. So then we add a second bulb to the picture here. When we do that, what have we done to change the voltage drop? Nothing. Each of the bulbs sees a potential difference of 12 volts. Each side of the 2 bulbs are connected together and have to be at the same potential. We could even add a third bulb. In fact, we could add as many bulbs as we like. Each bulb is going to see a voltage drop of 12 volts. This is the rule then for voltage drops in a parallel circuit. The voltage drop is going to be the same across each leg of that parallel circuit. So each of these bulbs gets the same voltage drop across it. So in a parallel circuit, currents add up, the voltage drop is the same across each circuit element. Let's now look at resistance. Finding resistance in a parallel circuit is a little bit more complicated than in a series circuit. Okay? The rule for resistors in parallel is that the total resistance is less than the resistance of any one branch, okay? The reciprocal of the total resistance is equal to the sum of the reciprocals of the resistance of each branch. So Ohm's law applies separately to each branch in a parallel circuit. And so to find the resistance, the total resistance in a parallel circuit, you add up the reciprocals. That's the reciprocal of the resistance. There you go. To summarize each of these parallel circuit rules then, we've got voltage drop is the same across a parallel circuit. The current adds up to the total current, and the resistance is less than the resistance of any one branch. So let's take a look at an example. Okay, so we have this happy little circuit right here. We've got 3 resistors in parallel, 58 ohms, 70 ohms, and 42 ohms, all hooked up to a 12-volt battery. We want to know the current provided by that battery and the voltage drop across each resistor. So generally, when we're faced with a circuit problem, what we want to do is we want to reduce that circuit to an equivalent circuit with one resistor that we can then work with. Because these resistors are in parallel then, we're going to use the parallel rule for figuring out our total resistance and then apply Ohm's law. Applying the rule for parallel circuits, we get this for the reciprocal of the total resistance, and therefore a total resistance then is going to be 18 ohms. Once we have this total resistance of 18 ohms, we can now apply Ohm's law to figure out the total current in this circuit. And we have to keep in mind we're looking for the total current here, so we can use the voltage from the battery and we can use the total resistance of the circuit, and we get 0.67 amps is our total current. Now we have to remember that because this is a parallel circuit, the current adds up through each resistor. Okay, so it's not, the total current is this 0.67 amps. The current through each resistor itself is going to be different. So if we were asked to find the current through, say, the 58 ohm resistor, we're going to use the resistance for just that resistor. Okay, so just that 58 ohms. But then what about the voltage drop? Well, the rule for voltage drops in a parallel circuit is that the voltage drops are the same across each resistor. So the voltage across each resistor is 12 volts. Okay, so that's the second part of the question. Let's take a look at, let's figure out what the current would be across that 58 ohm resistor. We're going to use that 12 volts. We're going to look for just that resistor. We end up with a current of just 0.21 amps. Okay. Now what you should do, maybe pause the video and go through this process for the current through the 70 ohm and the 42 ohm and make sure that they add up to 0.67. Okay, so that'll about do it for parallel circuits. Where we're headed now is into combination circuits, where we're having elements of series and elements of parallel in one single circuit. Prior to that, in the next video, we're going to stop and take a look at power in circuits and then how to measure resistances and voltages and currents in circuits. See you in class.